Today we are going to discuss about the topic digital signatures. So what is a digital signature? So digital signature is a mathematical technique used to validate the authentication or the integrity of the message or a digital document. It provides non-repudiation service between two communication parties. So whenever you send a message, it should the user will not deny to send that particular message, and that the receiving end also the receiver should not deny to accept that particular message. And it should have the valid share. Whenever you say digital signature has been applied, then we are going to validate that particular document with our keys. So how we are going to provide the digital signature? So digital signature mechanism that provides message authentication, message integrity and non-repudiation. So message authentication is nothing but whenever you are encrypting with the key, we are authenticating ourselves to the other person that we are sending the message. Second one is integrity. Whenever the digital signature is being done, we are providing the integrity that the document that we have sent is only known to the, you can only decrypt the data only to the known person. Then is non-repudiation. Whenever the document is being sent, it is not denied to send to that particular user B. Then coming to the digital signature process, so how it happens. So here Alice and Bob are there. So in Alice will send the message by using the signing algorithm, and he at the end of the receiving end, the Bob will do the verifying algorithm. So what are the need for the keys? So adding key of the digital signaturing process, how the processing of the keys does. So the message is sent from Alice to Bob. The Alice will send the message by encrypting with the private key, with secret key. Then using the signing algorithm, this particular message is sent to the receiving end. At the receiving end, Bob decrypts the information by using the verifying that signing algorithm as well as the public key of the Alice, and he decrypts the information and sees. So here you need to know about digital signature needs the public key system, and the signer signs her private key and the verifier verifies with the signer's public key. So signing the digest. So whenever the message is sent, the message from the Alice goes to the hash function. This hash function will generate a hash code, and it is encrypted with the Alice private key. And once you have done this, the signature, that is digital signature, is being done, and this data, this message is sent to the decryption end. At the decryption end, again they are going to apply the signature algorithm with the public key of the Alice and do the hashing function of that particular message and check whether the message received and the original message are same. If both are same, then that particular person is of validated. So achieving the confidentiality. So how we are going to provide the confidentiality? So always whenever you are sending the message using the digital signature, need not be encrypted with the separate encryption algorithm. So directly we are going to apply only one key. If only required, the confidentiality is being achieved. So see here, whenever you are taking the message, we are going to encrypt with that private key, Alice private key, using the signing algorithm. Then we are going to encrypt. So when you are doing the encryption, the confidentiality is being achieved. So encrypted with the Bob's public key. So Bob's public key we are going to encrypt. Then we are going to send that encrypted message to the receiving end. So they decrypt with the Bob's private key and also verify the Alice public key, and we are going to get the message. So here you need to know that always the digital signature does not provide the privacy. Only when required the another layer of encryption is being performed. So non-repudiation. So non-repudiation is an assurance that someone cannot deny something. So typically, whenever the non-repudiation refers to the ability to ensure that the party to a contract or the communication cannot deny the authenticity of their signature or a document. Then coming to the non-signature trusted party. So whenever you are sending the message, you are going to achieve the public keys. So we need to form a trusted third party where you are going to take the keys from this. So the signing algorithm, whenever the Alice or Bob will maintain a trusted center where the keys of the public keys are being achieved. So the Alice will take the message. She encrypts with the private key and with algorithm, and verifying algorithm that public key is being given to the Bob. He will get from the trusted third party. So this particular signature algorithm is being verified over here. If the verification is performed, then it is accepted by the Bob. So once this trusted sender trust the user A, then the communication from the user A to user B, the trusted sender, what it does is it verifies the whatever the message coming from the A to B is checked in the form of a trusted sender. If the verification is performed, the B should not deny to accept that particular message. So once this particular signing algorithm has provided the private key has been trusted sender, then we are going to directly go to the Bob and we are going to verify that particular message. Next, coming to the digital signature schemes, there are two types of digital signature schemes. So during few decades, there are a lot of digital signature schemes have been developed. In that, we have the RSA and DSS algorithm. So coming to the first one, RSA digital scheme algorithm. So here, the signing and verification of that particular scheme is being performed in this manner. So Alice will take the message. So this message is being encrypted with the Alice private key. So we are going to get the private key of that particular data, and we are going to send that particular signature document to the decryption end, and at the decryption end the Alice public key is being taken by the Bob, and this public key is being applied to that particular document, and we are going to get the value as m dash message dash. So this message value is rechecked with the message that is there, and we are going to see whether the message and the original message are both are same. If both are same, then we are going to accept the message, or else we are going to say that is not the authenticated person. So the key generation of an RSA digital signature scheme is exactly same as the key generation of RSA. So here we are going to use D as a private, E and N are the public keys. So you can see here. So we are going to apply the hash code. So in the digital signature, we are going to use in the RSA signature on message digest, that is MD. We are going to take the message. Then we are going to apply the hash function. Then we are going to apply the encryption with the Alice private key. Then we are going to send that particular document at the decryption end. The Bob will verify that particular document by taking the public key, and also he will apply the message, the plain message he is going to apply with the hash function and check whether the message that is coming from the Alice and the message document that is being decrypted are same or not. If same, it is accepted by the end user. So you can see here, we are taking the message, applying the hash function and encrypting with the private key of the A. Then we are going to append the message as well as the encrypted value ciphertext, and then we are going to send it to the destination end. We are going to get two blocks. One is the message, another one is the encrypted data, which contains the private key as well as the hash function code. Now this particular message is given to hash code, so hash function. So we are going to compare the hash function, and similarly this particular message is being decrypted with the public key of A, and we are going to compare. If both are same, then we are going to say authenticated. So coming to the signing of the digest, so you can see the similarly, that is the previous RSA algorithm, how does it work. So here we are going to take the hash algorithm. So only hash algorithm only works on the one-way hash. So we are going to take the hash code, then we are going to apply the private key, digital signature is achieved, then giving to the receiving end, the original data is being applied to the hash code. Then we are going to take the digital signature. From that we are going to apply public key. Then we are going to see both our hashes are equal, hash codes are equal or not. If it is equal, then it's validated and data integrity is existing. This can be also performed in the form of the even passwords, and where we are going to store that particular password in the form of a hash code, and at the receiving end, so whenever we enter any password, so it will check the hash code that are existing in the servers. So if the hash code is same, we are going to authenticate it, or else we are not getting authenticated for our mail IDs. Coming to the digital signature standards, the second algorithm. So here we are going to use, it is also called as digital signature algorithm. So DSA works on various functions, and it is also a hash function. So the working model of the DSS will be in the format of, see, we are taking the plain message. This plain message are given to the hash algorithm. So once you apply the hash algorithm, a hash code is generated. Then we are going to apply the key to that particular signature, and here we are applying two keys. One is the public global key and the other one is the private key of A. So public global key and private key of A, and also the one particular key, and this particular signature document is appended with the message to the destination end. So what we are going to get at the destination, we are going to get message, yes and R. So this particular message is again perform the hash function, and we are going to verify with the verification. Then S is being applied and R is also being applied. Then we are going to apply the same keys that are being applied at the encryption end. So the public key, the global key, as well as the public key of A. So when we are applying, we are in the R we are going to have the message, plain message. In S we are going to have the signature values. So we are going to compare those values, that is R document with the S document that is being applied, that is signature document. When we apply the values, so we need to get the plain text values. If the plain text has been got, then we are going to say that person has whatever the data that is sent by the user A is being authenticated as well as integrity is formed. So the functionality of the DSS algorithm is, global public key components. So in the that is whatever the public key of global you are applying, here we are going to take the primary prime number. It should be length of 2 power L minus 1, between 2 power L minus 1 and 2 power L, and it should be between the 512 bits and 1024 bits. And it L, that whatever the length we are taking, it should be the multiple of 64 bit. And Q is the prime divisor, that is P minus 1, and it should be between 159 to 160, and the bit length should be of 160 units. Then we are saying G value, that G value should be a formula h power p minus 1 by q mod p, where h is an integer which lies between 1 and p minus 1. So we are taking two prime numbers, 1 p and q. So this prime number should be of length 2 power l minus 1 to 2 power l, and q should be a prime divisor of p. So prime divisor is nothing but they should be of co-primes, where the GCD values of both the primes should be equal to 1. So here the h value we have taken, we have p, q values. Then we are going to take the private key value which is represented with the x value. This private key value or it can be a pseudo random integer. That random integer should be between 0 to q. Then we are going to take the public key. The public key value of y is calculated using g power x, that is g value power x values, that is private key what we have taken, mod p. Then we are going to calculate our secret number, user per message secret number. Randomly k value we are going to take. Then we are going to, at the receiving end, we have seen the S and R. So these are the two formulas. So R we are going to get G power K mod P. G is the value that we have assumed, we have calculated, and K is the value that we have randomly assumed, and mod P into mod Q. Then S is nothing but K inverse. So K inverse hash of h of m, that is hash value of m. Once we apply the hash function, that message value, the hash code value, plus x value that we randomly selected the private key, and r is the value that we have got, mod q. So this becomes the signature value of r and s. And w is the h dash of h dash inverse of mod q. So whatever the s value we got, that value inverse mod q. Then u1, u2 are the two values that we are going to calculate. So u1 is nothing but hash message into w value that we calculated, mod q. Then u2 is nothing but r value into the w value, mod q. And v value, that is g power u1 y power u2 mod p mod q. So like this we are going to verify. So if we get v is equal to r dash, then we can say both are being integrated and authenticated. So you can see the working model. So we are taking the message, applying the hash function, then we are applying the key to the function, and F2 as a P, Q and G, and this particular we are going to get R as an output. Then we are going to apply this value to the function, then apply X and Q, we are going to get signature document. At the receiving end, we are going to get M dash, S dash and R dash. This we are going to give the hash value, and we are going to get the function 4, which we are going to compare with the R value that is there, and we are going to verify. If the comparison is equal, then we are going to verify, say that user A is authenticated and thus with signature is being authenticated. So these are the formulas that we are going to use for this particular function.